Now let's take a look at the rotation of the C2-C3 bond of butane. So just like when we studied ethane, we are going to look down the carbon-carbon bond of butane, where specifically we're going to look at the carbon-2, carbon-3 bond. So this is, if you want to label these C1, 2, 3, and 4, we're going to look down the C2-C3 bond. So if we rotate it this way, now we have in front C2 and in back C3. C1 and C4 are the two methyl groups that are sticking up. So if we wanted to draw a Newman projection of this, we would see that we have hydrogens eclipsing, and we have now methyl groups eclipsing in the back there. We're going to track the dihedral angle of the two methyl groups for this exercise, and right now that angle is 0. After doing a rotation, you can see that the Newman projection would, in the back, still look the same. We'd have a methyl group sticking up and hydrogen off to the sides, but in the front this time, we're going to have H, and CH3. So now the dihedral angle between these two methyl groups is 60 degrees. So if we do another rotation and bring the methyl group down to here, on the front carbon, we have CH3, H, and H, and then of course still sticking up in the back, constant the whole time, are the methyl and the other two hydrogens. So now the dihedral angle between the two methyl groups is going to be 120 degrees. If we keep going, we now see that the CH3 group in the front is at the bottom. So we have this kind of picture with the CH3 and the CH3 in the back, of course. This is constant. And so we have a dihedral angle between these two methyl groups of 180 degrees. Once again, we rotate. So now the methyl group that was down here has been rotated over. So we have another eclipsed conformation. Of course, the back, this hasn't changed. In the front now, though, we have the methyl group off to the left and then the two hydrogens. So now we are at that 240 degree dihedral angle between the two methyls. All right, so if we continue, we've now done a rotation, bringing the methyl group that was down here. We've rotated that up. And so we have another staggered conformation. Once again, CH3, H, and H, nothing's changed there, but the methyl group now is here. Dihedral angle, we're now at 300 degrees. Finally, we get right back to where we started from, and we have the eclipse conformation like this, with the methyl groups eclipsing one another. But this time we are saying that, well, the dihedral angle is 360 because we want to track it that way.